It's your boy DK underscore typical TV, and today we're going to work with another Arduino Uno. Today we're going to be building 4 different circuits, and with these circuits we're going to have a bill of materials, which is going to consist of the Arduino Uno, breadboard, various wires and jumpers, multiple 220 ohm and 10k ohm resistors, a potentiometer, 3 push buttons, 3 standard LEDs, a LDR, a light dependent resistor, and a VTX Line Tracker. And the first exercise 4-2, we're going to be working with the pot, so the potentiometer. And as you can see, the potentiometer is the white and blue. We have it, there's 3 ports on it. One is for negative, one's for positive, and the middle one is the wiper, which is connected to, as you can see in our orange line, is connected to our input analog A0. And also, as you can see, the LED we're using is also with a 220 ohm resistor that's plugged into our digital, which is negative, or which is pin 3. And as you can see me turning, the point of this exercise was to have as you turn the potentiometer past a certain degree, which we set in our code, which you will see later on, once it gets past, or once it gets equal to or greater than 600, the LED will turn on, and if it's less than, it will turn off. And as you see, it's on, so it's greater than, or it's equal to or greater than 600. As you see in this code, we have the beginning, which is we set our inputs essentially, or our variables, I'm sorry, and then in the setup we have the pin mode, which is setting up our LED as an output, and we use an if then else statement to make the code essentially. So if using the if then else statement, so we have it set to where if the value is equal to or greater than 600, the LED turns on, or else if it's lower, or essentially if it's lower than the 600, it turns off. Now for our next exercise 4-3, we're working with a VTX Line Tracker. The VTX Line Tracker is it's a pretty basic setup. There's 3 wires to the VTX, which is red, black, and white. White being the controlling signal, which as you can see is plugged into our A-O analog, and then obviously the black and red, or the positive negative, as you can see, is plugged in and wired to the negative and black wire, which black wire is our ground, red wire being our voltage. As you can see in the code, we have in this code we're using an if statement. So if that line tracker sees a value less than 50, it shows you a white object. If it's between, I placed it 800 and 1300. Well, if it's above, if it's greater than 800 and it's lower than 1300, you see a black object, and everything else is basically unknown. So as you can see right now, I have it on a white, as it's showing a white line detection. That means that sensor is picking up white light essentially. And when it's on something it doesn't know, that's not black or white, you'll see it's on a yellow plastic thing I have. It's going to show you unknown detected. As you can see, it's basically picking up unknown detected, so I mean it's neither a white object or a black object. And for our next exercise 4-4, we're going to be using a PullUp PullDown circuit with push buttons and LEDs. As you can see, that the push buttons and LED are wired to the digital side of the Arduino. We have voltage going in through the 10k ohm resistors to the push buttons, so that's how they're getting powered, and the LEDs are being, wired to the negative, going through the 220 ohm resistors. But the point of this circuit build was to essentially, one button was to control the red light, as you can see now. Second button control the yellow light, and then both 1 and 2 turn on the blue light. As boom, and then the third button turns off all of them. Now, when you look into the code, you'll see here shortly, I have it programmed set specifically for that in the Arduino. So when you're looking at the code, the void setup is essentially setting each pin as an output and input. In the void loop, we use an if statement. So if, say, push button 1 was on, so essentially if it was off, not pushed, then when it's pressed, it would be on, which is high. And same goes on for the other 2 buttons. Same goes for the yellow button. When the second button is off, so I mean when it's open, the yellow light is off. So when it's pressed, as in the button being on, the light turns on and it stays on. And then goes for the blue light. If both 1 and 2 are pressed, that means the light turns on. And for the third button, when all the lights are on, essentially cuts them all off. So as for the next exercise 4-5, we're going to be working with an LDR, a light dependent resistor. So the main purpose of this lab is to write a code that would turn on the LED on below a threshold. So when it's dark, the red light, as you see, is on because the light's on. So when the light goes off, that light, I have a program set that the red light goes off and the other 2 lights come on. So that was the point of this circuit program. And as you can see, there's a set of numbers that the clear light that's programmed in is picking up a certain amount of values, which is around 900. So I had to set mine pretty high. As you can see, it goes from 900 to about 800. So that's why I use the if then else statement, and if the LDR, the dependent resistor, is picking up a value less than 950, it's essentially the red light is on and it's off. So now when I go to turn the light off, the blue and the yellow light come on. From this angle, you should be able to see both blue and yellow light on. So that means when the clear light is picking up a value greater than 900. And then when I look on the serial monitor, when I focus in, here you go. So the value is picking up about 1,023. So the value is greater than 900. So essentially, the red light goes off and the blue and yellow light turn on, as you see in the else statement of my code. Yep, looks pretty good. So we had to use 220 ohm resistors as well.